Okay. See, this is if plus is there, this is inductance. That is R1 plus JXL1. Similarly, Z2 is equal to what they are giving? 6 minus J5, J8. 6 minus J8 ohm. Then what is this?
R2 minus JXL2.
JXC. Because minus is there. If minus is there, it is XC. If plus is there, it is XL. If plus is there for J, it is XL. If minus is there, it will be XC. Okay. Now I'll draw the circuit. These two are connected in parallel. These two are connected in parallel. See here. This is your R1 is 10. And this reactance is J15. And your Z2 is 6 J8. 6 and minus J8. Okay. These two are connected in parallel. This is Z1. This is Z2. This is Z2. These two are connected in parallel. And the current and the total current supplied is supplied is
15.
Sorry. Total current supplied is 15 ampere. Okay, 15 ampere. And this is connected across the supply. And this is connected across the supply voltage V. That is connected across the supply voltage V. So this is the circuit diagram. Draw this circuit. So in series current is same, but in parallel current will divide. So here current 15 ampere. When you apply the supply voltage, current 15 ampere is flowing. This current will divide as I1 and I2, where I is equal to I1 plus I2. I is equal to I1 plus I2. Now here I am determining in the problem what he is asking. Read the problem.
Power taken.
Okay. Find the power factor. Okay. What is the power taken by each branch? Find also the power factor. Power factor of individual circuit and combination. Okay. First I am determining the equivalent impedance. One second. Z equivalent is equal to Z1 Z2 by Z1 plus Z2. That is equal to 10 plus J15 into 6 minus J8 divided by 10 plus J15 plus 6 minus J8. Now see here, in the denominator, 10 plus 6, 16, 15 minus 8. What is 15 minus 8? J7. 10 plus 16. In addition, it is rectangle form. Okay. Now multiply these two. Keep your calculator in complex mode. Keep your calculator in complex mode. I think you know how to keep the calculator in complex mode. Do you know?
But J where sir in calc?
No, directly keep your J is nothing but I. In your calculator, J is nothing but I. 1 minute. Okay, listen here. What I am telling. Keep your calculator. Go to mode in your calculator. Go to mode. In mode, complex is there. One is COM, another one is COMP. Is there?
Yes, sir.
Press that complex. Press that complex. Now you do one thing. Now you type this 10 plus I5, I15, 10 plus or 15I. 10 plus 15I into brackets you have to keep. You have to keep the brackets. Multiply into, again keep the brackets, 6 minus J8. How much you are getting? Multiply these two.
Not coming, sir.
It's not coming. 10 plus 15I. 10 plus 15I.
Yes, sir. 180 plus
How much
10.
Huh?
180 plus 10I.
180 plus 10I. Is it correct, remaining students? Is it
Yes,
correct?
sir.
Okay. Now divide these two. Keep the brackets. Brackets are very important and divide. Divide and tell me the answer.
Sir, 9.6 minus 3.6I.
Minus J 3.6. In your textbook, they are giving this answer.
Yes, sir.
Now convert this to polar form.
R equal 10.3. Theta
10
equals
point, okay. 10.39
minus 20.41.
minus 20.4. Here you have forget minus, I think. Take minus. Minus J 3.62. This is the total equivalent impedance of this circuit. This is the total impedance of the circuit. Now we know Z. Now I can calculate the total voltage. Total voltage is equal to I into Z equivalent. Total voltage is equal to I into Z equivalent. Your I is 15. I is 15. What is Z equivalent?
10.3.
10.3 at an angle minus 20.4. That is equal to, you'll get
154.5.
Are you getting this 154.4?
154.4, yes. 5, sir.
Okay. No problem. This is the voltage. What is this voltage? This is the total voltage of the entire circuit. V is equal to I into Z equal. This is the total voltage of the entire circuit. Now I am calculating I1. See here, what is the formula? In parallel, you can apply current divider. I1 is equal to, what is the current divider?
Opposite side current.
Okay. I1 is the current flowing in Z1. What is the opposite branch for I1?
6.
Z2. Z2 by total impedance of parallel circuit. This is I1. So calculate I1, you know I 15 into your Z2. Before doing this, you do one thing. What is Z1? Z1 is 10 plus J15. Convert this to polar form. Z1. Convert Z1 to polar form.
18.02.
18 at an angle 57.
56.3.
56.3.
Okay, in your textbook 57 they are giving. Similarly, Z2. Similarly, you do Z2. Z2 is equal to 6 minus J8. Convert this to polar form. 6 comma minus 8. That is equal to
10 minus
Theta minus
53.1.
1 minute. Your Z2 is 10 at an angle minus 53.1. Go through this. I am coming. This is Z2. I have told one note point. In multiplication, polar form is easy. In addition and subtraction, rectangle form is easy. Have I told this? Write a note. In multiplication and division, polar form is easy. In multiplication and division, polar form is easy. In addition and subtraction, rectangle form is easy. In addition and subtraction, rectangle form is easy. Now see here, I want to determine I1, current in Z1. I want to determine the current in Z1. Current I1 is equal to total current. I know total current into opposite branch, Z1, Z2 by Z1 plus Z2. Now it is division is there here. If division is there, which form is easy? Polar form or rectangle form?
Polar form.
Polar form. Now take the values of polar form. See here, I am taking ZQ. 10 at an angle. 10 at an angle minus 53.1 divided by, now addition is there here, Z1 and Z2. Take the rectangle form. 10 plus J15 plus 6 minus J8. Now this is 15 into 10, 150 at an angle minus 53.1 divided by 16 minus, plus J7. 16 plus J7. 10 plus 6 is 16. 15 minus 8 is 7. J7. Now convert this denominator into polar form. Convert this denominator into polar. I am removing this. I1 is equal to 150 at an angle minus 53.1. Convert this into polar form. POL 16, 7. How much?
17.6.
17.6 at an angle.
23.6.
23.6 plus, because here plus is there. Now divide this 150 by 17.6.
8.522.
8.523.
8.53 at an angle. If angle comes to numerator, what will happen?
Minus.
Minus 53.1 minus 23.6. Ampere. Is it okay? Similarly, I2 is equal to total current into, what is the opposite branch for I2? See the circuit.
I1.
Opposite branch for I2. Opposite impedance, that is Z1 by Z1 plus Z2. Now calculate. I is 15, Z1 is 18 at an angle 57 divided by Z1 plus Z2 is 16 plus J7. Already had seen here. 16 plus Z1 plus Z2 is 16.7. What is this? If you convert this, what is this one? 17.6 at an angle 23.6. Is this 270?
Yes, sir.
Divided by
15.3.
you'll get 15.3.
Yes, sir.
Okay. What is 57 minus 23.6?
33.4.
33.4 or 32.7?
33.
Okay. This is the current I2. Okay. Now see here.
Sir,
Tell
I1
me.
also 76.7, sir. Angle
Angle 70.
6.7.
Okay. Ampere. This is your I1 and I2. This is your I1 and I2. What is the okay? Z equivalent, we got this one. Listen here. Z equivalent. So what is this angle? The angle is phi. I have already told you, whatever the angle we are getting for Z, that is your phi. Then what is this angle? Z1 angle. What is Z1 angle?
Pi 1.
Phi 1. Z2 angle?
Pi 2.
Phi 2. Remember that Z1 angle is phi 1. Z2 angle is phi 2. Okay. Now in the problem he is asking power. He is not asking all these things. He is asking power. Power taken by each branch. Power in the first branch. P1. What is the formula? I1 square into R1. What is your I1? 8.53 square into R1. What is R1 in Z1?
10.
10. Your R1 is 10. This is your power P1 in the branch 1. First branch. How much is it?
727.6.
736 watts? I don't know exactly. 730?
727.
727 watts.
0.6.
Okay. This is your power P1. Next I am calculating power P2. P2 is equal to I2 square into R2. I2 is, where is I2? 15.3. What is R2?
6.
6. That is, how much you get?
1404.5.
How much?
1404.5.
This is your power P2. Now he is asking the power factor of individual circuit. Power factor of individual circuit. See here. Power factor 1 of first branch cos phi 1. What is phi 1?
57.
57. This is power factor 1 of first circuit.
0.545.
0.545.
545.
Lagging or leading? What is your Z1 R1 plus JXL? XL means
Lagging.
Lagging. Inductive circuit. First Z1 is inductive circuit. Now power factor 2. What is phi 2?
Minus 53.5. Leading.
Cos minus 53.1. Now tell me what is the cos 53.1?
0.6.
Okay, 0. Leading or lagging?
Leading, sir.
Because it is capacitive circuit. Your Z2 is capacitive circuit. It is leading. Now he is asking us in the problem is this, find the power factor of individual circuit and power factor of combination. Combination of Z1 and Z2. Combination of Z1 and Z2 means Z equivalent. What is your phi?
Minus 20 point.
Okay, power factor of the entire circuit. Combination. That is cos minus 20.4. It is cos phi.
0.93.
0.937. Leading or lagging?
Leading.
Leading. Why? See here, if you take the Z equivalent, you are getting minus here. If you are getting minus, it is capacitive circuit. If you are getting plus, it is inductive circuit. See Z equivalent, R minus J. Minus means it is leading. Angle also negative. If the angle is negative, it is leading. Capacitive circuit. Okay, your XC is greater than XL. If minus is getting here means in the Z equivalent, your capacitance is greater than the inductance. That's why your total power factor is leading. I think that's all about the problem.
Vector diagram. Vector diagram, sir.
Okay, now verify your answers. Your Z equivalent is this one, and total voltage is this one. I1 is 8.58, this one. I2 is this one. I1, I2 values you can verify. Approximately, you are getting these values. I1 and I2. C power P1. See the power P1, P2.
0.5.
Okay. 0.544. Power factor 1.
4 only.
Hmm?
4 only.
0.544. What you got?
That one only.
Okay, same thing. 0.545 power factor. This is power P1. This is power factor 1. This is power factor 2. PF2. Total power factor is 0.937 leading. Okay. Here also 0.6 leading. 0.6 it is leading. They are not given. It is leading. Now we'll draw the vector diagram. Now we'll draw this diagram, vector diagram.